Redox reactions. A redox reaction, or reduction oxidation, or also known as an oxidation reduction reaction, is one in which the oxidation number of an element changes from one side of my reaction to the other. So what it tells you to do in the instructions here is determine the oxidation number of each element in each compound, compare the reactants and products, and then if there's a change, then it's a redox reaction. So what I could do in this first one, I can look up my charge of Na from my periodic table, and I see Na is in group 1, so I know it's a +1 charge. It'll always bond that way, so it's +1 here and +1 here. Chlorine is the same way. Chlorine is a -1 always, and a -1 when it bonds because it's in group 17. NO3 is on my polyatomic ion sheet as -1, so it'll be the same way both there and there. And then Ag is silver right here, and it's a transition element, so I'm just going to look at the charge of what it's bonded with to know its charge. -1 would bond with a +1, -1 would bond with a +1, so I know it's a +1 charge in both places. Now, rather than go through all those steps, I'm going to show you the cheater's way. Here's the deal. Because all the charges stayed the same on both sides, I know that this is not a redox reaction. The charges did not change from the reactants to the products. And because these are already bonded with one another in ionic bonds, they're not going to change their charge. Once they've bonded ionically, they have transferred their electrons, and they're going to stay the same after the reaction. So if you see a double replacement reaction like this, where the two metals just replace each other, this will not be a redox reaction. However, if you see a reaction where there is a single element by itself and then it bonds to become part of a compound, you then have a redox reaction. The reason why is that chlorine by itself and any element by itself is going to have a 0 charge because it has the same number of protons and electrons when it starts out by itself, right? Like, remember when we were talking about atoms, that the protons and electrons will be equal until it gives or takes electrons to make that octet that it needs to be stable. So if I have an element by itself and then it becomes part of a compound, its oxidation will change because here it will be 0, no charge, and here it will have the charge that the periodic table says it will. In this case, since it's in group 17, it'll have a -1 charge. So if on any of these questions you see an element by itself on one side of the arrow and in a compound on the other side of the arrow, doesn't matter which side these are on, this could be flipped and it would still be the same thing. So by itself and not by itself, then that is a redox reaction because the charge has changed, and this will be true for any of these reactions. Again, if you don't have a single element on either side of the reaction, then these ions have already formed and it will not be a redox reaction. So go through, find the ones that fit this type of situation. So we put a Y here for yes, this is a redox reaction. Do the same for the rest of these, and then if you still have any questions, please come ask.